let's walk through some fur options and features. First, let's create fur. I can select object and create fur all around the object by pressing hair, create hair, or I can just select some faces and create fur just on these faces. So now in FurryBall, if I enable hair in render settings, there's my fur. All the options for these fibers can be found here in Furry Hair Settings node. We will go through them later. Now let's try some ways to define the shape of the hair, to style it. So first one is to manually move the CVs of these fibers. So I will select the lowest CVs per guide. Now I press F8, select CVs of the fibers, and I can just move them around, rotate them, scale them. I'll press F8 again. Now select more CVs per guide, and I can add more details. Now smooth it out by setting more CVs per guide. Okay, that's one way to style the hair. Next way is to use some hair modifications here in Furry Hair Settings node. So I will create hair all around the object for this. And here I can define bend angle and inclination to the surface, some waviness, randomness of bend, and kink. Next option is to connect FurryBall fibers to Maya hair system. So first let's create Maya hair system. These are the dynamic hairs, and now if I create FurryBall fur on the same object, FurryBall automatically connects the fur to these hairs. So if I play this, FurryBall fur is following Maya hairs. If I want some FurryBall fur I've created before to connect to this hair system too, I can do it here in hair menu under FurryBall. So connect to follicles. I will just select these follicles and the FurryBall fur and connect it. I can also bake positions of these CVs and disconnect it from Maya hair system. Now the shape of the fur has been baked and it's not connected to this Maya hair system anymore. So I can just delete it. Now let's walk a little bit through the fur settings node. First thing here, number of CVs per guide, options to update UVs from object, guide length, option to render fibers as B-spline, some visibility in renderer, smoothness of the fibers, density. We can map some density texture here. If we want our fur to be clumpy, we can set fibers per clump. Global scale of hair, length, billboarding, which means that your fibers will always face the camera. So orientation and orientation randomness. Offset map, so you can offset your fibers from the surface. That's usable if you have some displacement on the object, so you can map the same texture to this offset map and the fibers will match the displaced surface. And also length map. You can put some texture there as well. Length randomness probability, width of the fibers, randomness for that, and some softness, which works only if jitter is enabled in render settings. Next in here, settings for clamping, so radius of clamps, inclination to the center or outside, randomness for fibers inside the clamp, kink and mutant rate is connected to mutate color in hair colors. Next thing here are hair modifications, which I talked about before. Hair colors of root, tip, some variants of saturation, value and hue, mutant rate of hair with this color. You can put some textures in root and tip color, which will use UVs of the object. And body color is texture for each fiber. So let's try that. Let's make wider fur for this. Remove softness and not so many. by adjusting density map and fibers per clump. Now I will pick some texture with alpha channel, like this one, and my fibers became transparent here, and I can enable alpha mask, and this is very useful for creating vegetation. Bitmap fix is for fibers really far away. Root and tip color and variances works for texture, of course, too. So this is for after some shape adjustments. Now let's have a look at shading, because this is very dark. Now the fur is using mesh shading. I will turn on long hair diffuse to get better look. I could turn on specular. In vegetation shading is more advanced shading. Settings for it are here. You can choose front and back color for each fiber and map some normal map and thickness for translucency. Fur in FurryBall has its own shadow overrides, which can be found here in Hair Shadows tab. So fibers have their own filter size. You can use it to smooth out shadows in hair. Shadow volume is shading of the fiber from root. You can adjust white in shadow to get deeper shadows. This is also good for reducing noise when you are moving with lights in animation. Shadow intensity, shadow color, bias for shadows, and overrides for ambient occlusion. Now Fur is using standard shadow mapping. You can choose another two techniques for shadows in Fur, but they must be allowed in light settings. Note: Fourier opacity map and deep opacity map. Now when it's not enabled, it uses the standard shadows no matter what is chosen here. And I recommend you to experiment with these two. You can get more realistic and better looking results. And the last thing here is override for color bleeding. This is an example of vegetation shading. I've got leaf front and back color textures here. Some normal texture and yellow color as thickness. For translucency, I've got translucency enabled in light settings attribute. And here, in the back of the teapot, I can see my translucent leaves around the edges. FurryBall can also render Maya fluids. I've got one container created here. I turn fluids on in render settings. My fluid container is already rendering, but it has these artifacts in shadows. To prevent that, I must enable depth jitter in render stats in fluid shape, and for better control of rendering this fluid, I will add fluid attribute node. First thing here is ignoring environment fog. Next, override for samples per voxel to set up rendering quality. So now you can choose samples and directly control quality of the fluid. Noise unit scale is attribute that controls texture scale for fluids. So if I enable texture here, this attribute controls the scale. These are attributes for computing depth for fluids. This is to adjust priority of rendering when you have multiple fluids next to each other. And this curve here is for more detailed control of drop-off shape. Next thing here, attributes of shadows. You can set up completely transparent shadows, for example, and adjust filter samples for shadows. Phase function can boost your fluid for better looking results. I recommend to experiment with it. Now let's import some Maya fluid examples from Visor and render them in FurryBall. For this fire here, again we have to turn on depth jitter in render stats, and now add fluid attribute node and increase volume samples. Now let's try some clouds. These clouds have a different scale, so let's change it. Again, add fluid attribute node, and here can make the scale lower and also use override and enable the jitter. FurryBall also supports fluid self-shadowing, and I will show it on the first fluid. So let's make it more opaque. For self-shadowing to work, we must enable Fourier opacity map in light settings node, and let's set number of targets to some higher value. And now if I lower shadow transparency down, you can see that the fluid is already shadowing itself. In this scene I have end particles which are instancing this cylinder here, and you can see that instancing works just fine even without particles enabled in render settings. Next particles I have here are multipoint particles. So to see them in FurryBall I must enable particles in render settings. And I will make them depth sorted. And I will use lighting for them. You can see that these particles are self-shadowing. It's because I have Fourier opacity map in my light setup. It wouldn't work without it. Again, for better rendering control, I will add FurryBall particle attribute node. And with particles it's difficult to select it because Maya doesn't show it here, so it's better to open hypergraph and center on particles, and then your particle attribute node appears here and you can select it here. Like with fluids, I can adjust shadow transparency here and shadow opacity multiplier. These are for adjusting depth channel of these particles. Third priority is for better control of sorting particles and fluids together. Opacity bias, option to ignore environment fog, to not draw motion vectors, and to post-process blur these particles. Attributes for adjusting streaks and points, and remapping for opacity, hue, saturation and value. If you want to add depth of field to your scene, the easiest way is to first turn on depth of field in render settings, select object you want to focus, and in FurryBall select focus unselected. This will create a locator which represents focus point for depth of field. And if you select camera and roll down to depth of field, you can see that focus distance is automatically calculated, and now you can just adjust f-stop and focus region scale. which will enlarge the focus area. When you are adjusting depth of field, it's good to enable show focus range here in render settings under depth of field, which will show the focus area in red, and you can set up it exactly where you want it to be. Another handy thing here in render setting is option to use super sampling resolution for depth of field. That's useful in cases when you have really deep depth of field and some thin objects like hair on the edges, and edges of these thin objects can become creepy, and this is a way to prevent it. Here you can select shape of your bokeh. I will make few of some shining objects in the scene so we can see some bokeh. So now I can see the shapes of my bokeh. I can set up maximum bokeh size in screen space. And if I have some large or small scale scene, I can adjust depth of field by using unit conversion. And to render with motion blur, just enable motion blur in the render settings and set from how many frames do you want to motion blur to compute. FurryBall is also able to render motion vector paths, which you can use to create motion blur in post-production. Except rendering directly into the viewport, FurryBall is capable of rendering into the render view window. If you select FurryBall as renderer, press render, you have your image here, even with alpha channel, and you can use all the features from render window as rendering in test resolution and using region render. To render animation, output node is used. You can find it in FurryBall menu, output settings. Here you can select camera from which you want to render a resolution, which you can derive from Maya or choose your own one. You can render only part of the image. You can even fill these values of from the region here. This is for blurring the edges of this region you will render. Here you can select multiple render settings nodes you want to render, so you can have, for example, one for beauty pass and another one just for ambient occlusion. And render them together by selecting with Control. Here is path to output file. You can use variables like name of the render settings node, CName, camera name, and other options for gamma correction, choosing of format, and options for stereo rendering, and for OpenExer format you can choose which channels you want to include, and then sequence for rendering animation and range.